Hello everyone. So these are the second molecule that we'll be looking on. This is ammonia. Okay. So this is the 3D visualization of ammonia. So as you can see, the blue dot here represents ammonia. So the white represents hydrogens. Okay. So our first step is to identify the principal axis of rotation. So we have a C₃ as a principal axis of rotation. So I'll indicate that. Okay, let's indicate that. So this is it. So this is the principal axis of rotation. It's an imaginary line that passes through nitrogen. Okay, so that's it. As you can visualize it keenly. So as you can see, that's it. Now, let's identify the symmetry elements. Okay. So we had defined and said every other element, every other molecule has an identity. Okay, so that's our first symmetry element, and then we are saying it has a C₃. Okay, and to this C₃, every other time you can perform a C₃, that's a rotation by 120. It means also you can perform a rotation by 240. Okay, so it means that's a C₃². Okay, let's visualize what's a C₃. Okay, so you are rotating this molecule by 120 degrees. I want us to visualize that. So you are rotating this molecule by 120 degrees. It leaves the molecule to be indistinguishable. So if, and again, if you rotate it by 240, which is just similar as rotating it by 120 to the anti-clockwise direction. So the C₃ inverse represents the C₃². It means you're rotating it by 240 in the clockwise direction, and also you can rotate it by 120 in the anti-clockwise direction. So in similar case, it will bring you to an indistinguishable form of the molecule. So those are the visualization of those, as you can see. Okay, so let me indicate this way. Okay, so we have already established C₃, C₃², which is just C₃ inverse, and then we have established identity. So let's establish the reflection planes. Okay, so that's the first reflection plane. So we had said it's parallel to the principal axis. Okay, so if it's parallel to the principal axis, this is how you visualize it. So it's cutting through the nitrogen hydrogen bond. Okay, and it's parallel to this principal axis. So it will reflect this hydrogen and this hydrogen. Okay, if it reflects these and these, it will bring the molecule to an indistinguishable form. So we'll say we have established the sigma V prime. Okay, we can say sigma V prime, sigma V double prime, sigma V triple prime, or sigma V prime, sigma V double prime as we continue. So it has three sigma V's. So I'll indicate all of them. So the second one is when we are considering this other hydrogen. So we'll have this reflection plane. Okay, and then if you consider the last hydrogen, so let's consider this last hydrogen. If you consider this last hydrogen, we are saying, okay, sorry for that. So let's consider this last hydrogen. So the last hydrogen is here. So these are the three sigma V planes, the way you can visualize them. So this first plane is reflecting both these and these. Then there's this other plane that's reflecting these and these. And then there's this other plane that's reflecting these and these. Okay. So that's all for this. So we have identified the symmetry elements and have visually shown you what are the symmetry operations, how they occur. Okay, so please like, share, and subscribe to the channel, and have a lovely day.